Welcome to the NMINA video tutorials on CSP technologies, Block 6, Unit 7. My name is Nicole Janot and I shall give you an introduction to the basic functionality of data loggers. Test data is usually identified by the time signals. Therefore, the timing and the date of the logging system is vital to later reference the data points. At the beginning of any measurement, the time and the date need to be checked properly. Furthermore, test campaigns involving many signals may require several devices for data logging. It is vital that all internal clocks of those logging systems be absolutely synchronous. Only then can the data points be referenced by their timestamps. Furthermore, in preparation of the data logging, the basic settings of the logger need to be checked. This comprises the battery level and the available storage space for the data. In preparation of the logging, we first connect the sensors to the logger. In the case of this particular demonstration, one data logger will be sufficient. We then turn to the logging channels and verify the sensor information. In this case, the sensor is clearly identified by a name, the average mode has been set to cycling, and the limiting values are correct. And once everything's been set up properly, we can start the measurement. To this end, we introduce the sensors into this water. When we start the logging process, the signals are recorded, and we can monitor the readings on the display. As you can see, the signals of the two sensors introduced into the cold water agree very closely. If we then take one sensor and switch it into another pot with hot water, you can observe the temperature to rise. And as we put it back into the cold water, the temperature drops again. For the sake of this basic demonstration, we can stop the logging process at this stage. Once our data has been recorded, the loggers are then connected to a computer and the data is read out. On this graph of temperature versus time, you can observe the characteristics of the two signals we just recorded. First of all, both temperatures are relatively low and they agree closely, so the curves lie one on top of the other. Then one sensor temperature rises, drops slowly as the hot water decreases, and so does the temperature signal. The sensor is reintroduced into the cold water, the temperature signal drops again to eventually reach the same level as the other again.